moving on, we're going to talk about this idea of linear equations. We're going to keep talking about input, output, domain, range, how these all tie back together. So let's first look. Here we have a function, right? 2x minus y is equal to 5. And what we're going to do is we're going to take a look at some ordered pairs, and we're going to look at the pairs and see if they actually work for this function. So here's a possible solution. We have 1 comma negative 3. So 1 comma negative 3 means that 1 is the input and negative 3 is the output. So what I want to do here is I'm going to test and say, all right, if I plug in 1 for the input here, will the output result in negative 3 for this function? So I'm going to plug those points in to see if they're actually valid, if they work. So I'm going to do 2x minus y is equal to 5. I'm going to plug in the 1 here, right? I'm going to plug in 1 for x. I'm going to plug in negative 3 for y. Notice I like to use parentheses and drop in the exact number right into my parentheses. This helps to eliminate any mistakes I do with, especially with subtraction and negatives. So then I can see that I'm subtracting a negative 3, right? Subtract negative 3, that makes 2 plus 3, because really what you're saying is what's the difference? Is the difference between 2 and negative 3, is it 5? Well, 2 is 5 above 3. So that would be true, right? 5 is equal to 5. That's what it's saying. So that means that 1 comma negative 3 is an actual solution to this function. So here's my function. Does this input result with this output for this function? You test it through the process. The answer is yes. Okay, so we know that 1 comma 3 is a solution, right? When I plug in 1, negative 3 is a result for that that function. All right, here's one, 4 comma 7. I want to say if I plug in 4, will y result in 7 for this function? 2x minus y is equal to 5. Okay, so same idea. Plug in the numbers, and you'll notice that when I finally get to the end, I get 1 on the left side. Well, 1 is not equal to 5. That means that 4 comma 7 is not a solution. Okay. So there's a whole list of, there's a, for each domain, I'm going to get a range, and there's going to be a whole set of, a whole set of solutions here for a bunch of x's that pair with y's. Well, 4 paired with 7 is not one of those pairings, right? If I plug in 4, I can plug in 4 there, I just won't get 7. Okay, I get something else. So that's what it's saying. If I plug in 4, does 7 work? Nope, it doesn't in that case. All right, so here's another function, and this is actually written in slope-intercept form, sort of function form. Y is equal to 2x minus 1. Function form would look like, or function notation would be f of x is equal to 2x minus 1, right? Where this, right, f of x is equal to y. I'm saying that the output, the function of x, and the output are the same thing. Okay, so let's go ahead. We're going to make an input-output table. Okay, so when I graph something like this, what I want to do is I want to create a list of pairs. Okay, well, you can put in whatever you want. You can create a domain. Typical domains tend to be negative 2, negative 1, 0, 1, and 2, maybe 0, 1, 2, 3, 4. A lot of times you want to use 0. You want to use maybe a negative or 2 and a couple positive numbers. And you use these just to make sure that you sort of get a good understanding of what it looks like. And 5 is a pretty good number of points that you can use to make to graph it. Sometimes you need more. I would suggest not doing much less. So I created an input-output table, right? So I create a set of domain, or a domain here, right? A set of numbers that I want to use to plug into this to see what happens, right? So I'm going to plug in negative 2, work it out, see what happens. I'm going to plug in negative 1, plug it in, see what happens, and I'm going to go through all those. We did this earlier in the chapter, so I'm not going to walk you through that whole solution, but when you do this, you end up with these pairings. Here's your range, okay? So my range is negative 5, negative 3, negative 1, 1, and 3 for my domain of negative 2, negative 1, 0, 1, and 2. So this is saying as I plug in negative 2 into this function, the result of that is going to be negative 5. Okay? And so what that looks like is I can create points, okay? My input-output table then turns into a set of points, right? Then these points are another way of saying when I plug in negative 2, the result of that is negative 5. When I plug in negative 1, the result of that is negative 3. Okay, so I have a table, I have a set of points, and then what I'm going to do is I'm going to take these set of points and I'm going to represent them graphically, right? So I'm going to show them. I'm going to create like a picture that shows what these things look like. So I'm going to plot those points on there, okay? And each of these points corresponds to a location on this graph, okay? So let's say, I've got -2, 5, so there's a point, right? There's a -1, 3, 0, -1, 1, 1, 2, 3. Okay, and those points all correspond with these locations on the graph, and you can draw a line between those, and the line suggests that there's a pattern going on. Okay, and that's what we're looking for, because then perhaps we can generate a rule. And as you can see, really what's happening is as your input increases by 1, right? Every time you increase your input by 1, your domain by 1, the result of that, or your range, goes up by 2. And that's what this is saying, okay? That's why you're multiplying by 2. Okay? Right? Let's try another one. Why don't you go ahead and why don't you generate a list of range, or a list of outputs for that input table right there, okay? Go ahead and do that right now. All right, so this is 1 minus 3x. My suggestion, again, on these would be to take y, right? And we have it solved for y. This is why this notation works so nicely, because 1 minus 3, and then plug in each of these numbers into there. So if I plug in -2, you'll notice -3 times -2, +6. Okay? And so what you should end up with is 7, 4, 1, -2, and -5 paired with those. Okay? Well, that's going to create a set of points, which, when we plug them onto our graph, are going to be represented at these locations, right? So -2, 7, -1, 4. I've got 0, 1. I've got 1, -2, and I've got 2, -5. Okay, so each of those. Right, those points. Here it is in table form. Okay, each of these points written as a point. Right, this is what it looks like as a graph. Okay, and it makes a straight line. There's a pattern that we can suggest. We can then look at this and take a look at interpret some results from that. Okay, so here's another one. Why don't you go ahead? You try this one now. Well, why don't you go ahead? Try make an input-output table and go ahead and try creating points. I wouldn't graph it yet, just in case you get the points wrong, but just create the points. All right, go. Okay, so as you can see here, I actually said let's put it in function form. Now you might have created a table where you did -2, -1, 0, 1, and 2, and you probably ran into this issue of when you did it, you had to keep solving this problem over and over again the same way, right? Whatever you plugged in here, you ended up having to multiply by 4, and then you had to use the additive inverse and put it over here, and then divide by 2. Well, if you think back to what we did in one of our previous standards, where we were rewriting equations, right? We solved the equation for a specific variable. Well, that's what we did here. That's what I'm saying here is let's solve this equation for the variable y. Let's solve it for y first, and then what we can do from there is we can then plug in our inputs, and it will be much easier to get a set of outputs. So first thing I'm going to do is I'm going to add 4x to both sides. I get 2y is equal to 8 plus 4x. Then I'm going to divide everything by 2. Yeah, I moved the x's. That's another way, right? This is a -4x. Another way you can look at it is move it over here. It comes +4x. Then I divide everything by -2, or divide by +2, and I get y is equal to 2x plus 4. Now notice, I sort of skipped a step here. This is 4. This is 2x. You usually want to put the x in front, all right? Because if you think about this, what are you going to do? You're going to end up multiplying by 2 first, and then you're going to add 4. So it just puts it in the correct order of operations. Okay, so here's your this is your function. Why don't you go ahead, create points, an input-output table, or a pairing of inputs with their outputs, and then plot those points on the actual graph. So why don't you go ahead and do that now? All right, so this is the table that I came up with: -2, 0, -1, 2, 0, 4, 1, 6, 2, 8. When you plot those points, you get this nice line that looks something about like that. And there you have it. Okay, and that's pretty much the whole idea here. Couple quick ideas though, just to make sure that you understand this, is y is 2. This is also a line. This is sort of saying the output is 2, right? When you say it, this is why I want you to understand that y is range, is the output. So what we're saying is the output is 2, and if the output is 2, it sort of means it doesn't matter what you plug in. My output is 2. Y is 2. So what is that going to look like in a graph? Well, that's going to look like a horizontal line like this. Okay, that is where y is 2. All right. Well, then what's x is equal to -3? Well, that's saying is what you're doing right there is you're saying my input is -3. I don't care what my output is. So that's going to look like a vertical line, okay? That vertical red line is everywhere where x is equal to 3. This is everywhere that my input is -3, okay? And that's it. We'll see you tomorrow. Bring your notes, and I'll check them in tomorrow.